For this video, we're going to be discussing drawing graphs for real-world situations. So when we're going to draw a graph for a real-world situation, we have to first figure out whether we're talking about an equation or an inequality. I've got this table, and a lot of these words you've seen before when we were doing word problems. And these are just some common words that will help me to figure out whether I'm talking about an equation or an inequality when I am working with a word problem. So for equal, we've got equal to, same as, exactly, is equivalent. These are all tell us that I'm dealing with an equation. And then I'm not going to go through each one of these. You can write them down. We've discussed them before. These are all words that will help me decide whether a problem is telling me whether it's a greater than problem, a less than, a greater than or equal to, or less than or equal to. So once we have an equation, and I should say an equation or inequality written, we're going to use any of the methods that we know to graph the situation. By any methods, I mean finding x and y intercepts, or by finding a point and slope. So let's take a look at a problem. It says Alex is participating in the school fundraiser. He's selling candy bars for $1.50 regular candy bars for $1.50 and large candy bars for $2. Alex wants to sell exactly $300 worth of candy in order to win a prize. I want to write and graph a relation to model the situation. So first thing I want to do is decide what kind of problem I'm talking about. We see this keyword exactly here. This is telling me that this is an equation. All right, and all of our equations and inequalities for this are going to have two variables. I've got to have an x and a y in order to graph these. So I'm going to say that x is going to be my number of regular candy bars, and y is going to be my number of large candy bars. I'm going to use these to graph this. So I need to write an equation. Well, I know that regular candy bars cost $1.50 and large candy bars cost $2. So if I think if I take 1.5, multiply that by x, that's going to tell me how much money I make, or how much money Alex makes from selling regular candy bars. And if I take 2 and I multiply it by y, that's going to tell me how much money Alex makes by selling large candy bars. So I can say 1.5x plus 2y equals $300. Because this is the amount he makes for regular candy bars, this is the amount he makes for large, and this is the amount of money he's going to make altogether. So now I need to graph these. And what I'm going to do is I am going to do this one by finding both the x and the y intercepts. So I know to find the x-intercept, I plug in 0 for y. That just makes this 0, so I say 1.5x equals 300. If I divide both sides by 1.5, I get x equals 200. So I know my x-intercept is 200, 0. Similarly, if I plug in 0 for x, I get 2y equals 300. Divide both sides by 2, I get y equals 150. So my y-intercept is at 0, 150. All right, now, you'll notice I already have a pre-made graph here. And for many of the problems that you're going to be doing, you're going to have to come up with the scale of your graph on your own. I noticed that my x-intercept is at 200. So I decided to set my scale up as going by 50s so that I have some room and I can see that 200 is on there. And I see that my y-intercept is at 150, so I decided to do my y-intercept also my y-scale also by 50s. So I know that these are my 2 points right here. And now all I need to do to graph is draw a line that goes through these 2 points. And you'll notice that I only worried, I don't want a white line. You'll notice that I only worried about the positive quadrant of my coordinate plane. I only worried about quadrant 1 here. And the reason behind that is there's no way for me to sell negative of either type of candy bars So there's no point including the negative parts of the graph. I only include the positive. Now, I don't have to do any sort of shading with this graph now that I've drawn in my line, because since it's an equation, only values that are on this line are values that Alex could sell and make his $300. So if we look at this, we can figure out some points that are on here. Like if we look at x is 50, we get y is, what is this? 1, 2, 3, 4, 110. So 50, 110. Let's see if that works for our problem here. 1.5 times 50, that's 75. And 2 times 110, well, that's 220. That only gets me up to 195. So maybe that's not exactly, or that only gets me up to 295. So that's not right. That isn't exactly perfect. But if we looked through here, we would find values where any values that are on this line are solutions to this problem. They're all the different ways that Alex could sell candy bars and get $300. So let's take a look at another problem. It says Amara goes shopping. She wants to buy some shirts and some pants. Shirts cost $25, and each pair of pants costs $50. She can spend at most $150. Write and graph a relation for how many pairs of shirts and pants Amara can buy. So let's start by defining both our variables. I'm going to say x is the number of shirts that Amara can buy, and y is the number of pairs of pants. So if I take 25 and I multiply it by x, that'll tell me the amount of money she spends on shirts. If I take 50 and I multiply it by y, that'll tell me the amount of money she spends on pants. And I need to decide, is this an equation or an inequality? Well, I see right here, at most. At most tells me less than or equal to. So my inequality ends up looking like 25x plus 50y equals 150. So once again, I'm going to find both my x and my y intercepts. So 25x equals 150. That tells me x equals 25. No, not 25. X equals 6. So I've got 6, 0. And then I say 50y equals 150. Divide both sides by 50, and I get y equals 3. So that's 0, 3. Now you see I set my graph up here. I counted by 2s up to 10. That's fine. That'll let me see 6, 0, and 3. So 6, 0, that's right here. 0, 3, that is right here. All right. I want to draw my line between them. It's a less than or equal to, so that is going to give me a solid line. And now, because it's less than or equal to, because this is an inequality, I have to decide which way I'm going to shade. So I'm going to pick a point. I'm going to pick 0, 0. If I plug that in, 25 times 0 plus 50 times 0 is less than or equal. This should say less than or equal. Less than or equal to 150. That's 0. That's 0. 0 is less than or equal to 150. Well, that is true, so that I want to shade in here, because anywhere in here are answers to this problem. For example, if we used, say, 2, 1. 2, 1. 2, 1, that is 2 shirts and 1 pair of pants. Well, 2 times 25 is 50. 1 times 50 is 50. 50 plus 50 is 100. Which is less than or equal to 150. So that works in this case. All right? So our answer is simply this graph right here. All right, example number 3 says Andy works at a job where he makes $500 per week plus a commission of 10% on his sales. Write and graph a relation that represents this situation. Well, if I define my variables, I'm going to say x is the amount of sales. I'm going to say y is the total amount of Andy's paycheck. All right? And we know 10% that is 0.1. So if I want to write an equation to represent this, I can say y equals 0.1x plus 500. All right, so now in this case, I'm going to use the slope and a point to find, to make my graph here. So I know one point on here is the y-intercept, 0, 500. You'll notice I have my graphs going by hundreds here. So 0, 500. All right, and I've got 0.1. Well, that's 1 over 10. All right, so 1 over 10. So if I think about this, if I plug in, say, 200 here, let's figure out how much Andy would make for $200. That'd be 0.1 times 200 plus 500. Well, 0.1 times 200, that's 20 plus 500. That's $520. So at 200, Andy is at $520, which is right there. Okay, so now I need to just draw my line. This is an equation, so it's obviously a solid line, and it just goes like that. All right, so this is how I would graph it. Andy's paycheck gets slowly bigger and bigger and bigger depending on the more items he sells, or the total amount of his sales. All right, this is an equation, so I don't have to do any sort of shading at all. I just have to draw in my line. So I'm going to leave you with tonight's try it problem. It says a movie theater is selling adult tickets for $12 and child tickets for $8. The theater wants to make at least $9,600 today. Which table below illustrates the situation?